All right, so this is a Intro to Tech Assignment C, which is the Taylor Polynomial assignment, and I'll also give you a look at the bonus. All right, so I'll do that all in one shot. All right, so what you're going to do is you're going to go to Groups, go to My Groups, and then select the relevant group. So in this case, it's Calc 2, Summer 2019, and so that'll bring you to this page. And so first you're going to click on Taylor Polynomials, so it brings us to this tab. All right. Now this one I think is pretty straightforward because we've actually already covered the Taylor Polynomials and Maclaurin Polynomials lessons. Anyway, in lecture. So you have hopefully a little bit of a sense of what this is all about. But I'll just read the blurb here. The purpose of the activity is to explore Taylor polynomials and why they work the way they do. When working through this activity, you will not need to turn on g of x, h of x, or I of x. You'll only need to consider p of x, q of x, r of x, and the slider associated with constant c. All right. So c instead of a. So I'm going to hit restart on that because I actually did some work with this already. Anyway, so you can see here that there are functions g of x, h of x, and I of x. If I were to turn them on, you know, hit or miss as to whether they appear anyway. Because this is e to the x, it would just overlap with the e to the x that's already there. So for example, if I just unclick e to the x and then click the derivative, it just takes the place of it, so it's overlapping. Okay. Anyway, those three functions are embedded in the Taylor expansion, right? So p of x is accounting for the first derivative only. Q of x accounts for the result of p of x added to the term of the expansion involving the second derivative. And r of x involves the sum of the previous stuff. So basically q of x, which is already p of x, plus another term, and I'm including a third term. All right, so as you work your way down the line, you get more and more terms to the Taylor polynomial. Right, so what you're going to have to do is account for two things. The c value, so if I manipulate that, it changes things. Now, it can be kind of a mess here, so my recommendation would be look at these graphs one at a time. So turn off q and r, and just leave on p. The original function in p, and just scroll around, right? See what's going on. Make some mental observations. All right, so then turn that off. Turn on q, scroll around, same idea, mental observations. You don't have to write anything down yet. Then r, scroll around. All right, see what's going on. Then it's asking you, and this is where you have to draw a conclusion, which model p, q, or r seems to be the best approximation for function f. That's based on your observations, right? So you don't really have to do any math there. You're just looking at the picture. For 2, it's using the slider. So if you had all three graphs available to you, just think of it that way. If you're working with all three graphs, which c value would allow for the greatest degree of accuracy, no matter which one you are working with, which function, p, q, or r, right? Which c value would allow p to be the most accurate, then q, and also r, right? So then you do the same exact thing for the new function, this time the sine of x. So we're playing around with different functions also. A little beefier, x cosine x. Where are we here? Then we have 2e to the x minus 3, so a transformation on function e to the x. So playing around with that a little bit. And then some follow-up questions. So for each exercise, we used at most a third derivative. If you had a choice in the matter, what would you like to use? How does c relate to the accuracy of the Taylor model or Taylor polynomial? And so number 10 is asking, what is a Maclaurin polynomial? So that's really asking for a definition. And how does it relate to the activity? And I write, feel free to research this because, if you don't know the definition, then it's something that you would look into. Right? So go ahead and Google that or look through your notes. But what I would like you to do, don't just copy and paste the textbook definition, because that's not going to convince me that you actually understand what a Maclaurin polynomial is. Right? So paraphrase it, put it in your own words. All right? So that's the tech assignment C. And then the bonus, that's different, completely different. It's strictly related to unit circle trig, which is, again, a recurring theme of the course. So you're going to interact with the resource, this resource, for a minute or two. I don't know why I wrote that. I mean, do you need to do it for specifically a minute or two? No. Just slide the slider, take note of what's going on. When you have a pretty good sense of what's happening, then you're done with the slider. All right? So what you should be looking at really is the components. You have the unit circle, what's changing, what's not changing. That horizontal line segment is not changing. Right? That's going to stay at 1. The vertical line segment and the hypotenuse are definitely changing based on that slider value, and it seems to be coinciding with the point on the tangent curve. All right? So you're going to think about why the purple arrow represents the value of the tangent of the angle and how you know it, so an explanation is required. That explanation could be just a description of the math that you would use to make that determination. That's fine. Right? It doesn't have to be an essay. If we keep going around the circle past pi over 2, what would the graph look like? Right? So as I slide to the right, you could see that theta is getting bigger and bigger. Eventually it goes vertical. So what that's asking is, what would happen if I were able to go the other way? Right? So, and the third question, why are there vertical asymptotes? Right? Really, if you just paid attention to what I did with the slider a moment ago, I think that kind of answers itself. So you should be good to go there. The one thing that you need to consider for this is that this is a bonus assignment that's worth 3 bonus points. It's all or nothing. All right? So if you get any part of it wrong, you're not getting the points. All right? So be very careful. Take your time with it. Don't rush your way through it. All right? And that will do it.